All right, so we're going to look at general forms of equations. So the general part that we're going to look at, you can have a sine, and then sometimes they'll use parentheses and do bx, and a cosine bx. So I'll put parentheses on one, not on the other. Sometimes they use them, sometimes they don't. It depends on what else is going on in the equation. So you could put a little thing, parentheses optional. The amplitude, I think you guys did figure out from the lab pretty well, is the absolute value of A. So it's always positive. That's why we say there's an absolute value, because it's just how far it is from the midline to the top, midline to the bottom. And if you have an equation where they give you a number in front of x, we use that to find the period of the function, which we call capital T. And you take 2 pi, which is the normal period for sine and cosine waves, and divide it by the absolute value of b. So whether b is positive or negative, you're just using the number, not the positive or negative. And over here, I'm going to write also, if you need b to put it into an equation, you can take 2 pi divided by the period, and that also works. If you rearrange the equations, the 2 pi ends up on the top, and you divide by that number to get the piece that you want, either the number that goes in the equation, or you can use the number in the equation to find the period, just because that's what happens with fractions when you rearrange the equations. Okay, so down here, our directions say, find the amplitude and period for each given trig function. Note any reflections or translations. When it says note, what I'm actually saying is write them down. There was a discussion with this last year. You don't note it mentally, you note it on the paper. That's what we're looking for. Any reflections or translations from the parent graph, so like it's going up or down, if it's being flipped over. You talk about all of that. So these are the parent graphs, sine x and cosine x. We looked at that a little bit yesterday, and you saw it in the calculator lab. So we have y equals 3 sine 4x. So we're first going to find the amplitude. So we don't have to graph this on the calculator to find it. It comes from this number right here. It is the absolute value of 3, which is 3. And that gives you an idea how tall this wave function is going to be. If you're looking at sound waves, the amplitude gives you an idea how loud the sound is. The bigger, the more amps you have, the louder the sound.
How loud is it?
And then if you want to find the period, we use the number here in front of x. So this is the b that's in that equation. So you take 2 pi and you put it over 4 and reduce the fraction. So 2 over 4 reduces to 1/2. We get pi over 2 for the period. And there's nothing added onto the end to move it up and down. I don't have any negatives to flip it over. So that's all I have to do on that one. Okay? If we go to number 2, let's start with the amplitude. So the amplitude is going to be the absolute value of -4. That's your coefficient in front of the sine and cosine. So the absolute value of -4 would just be 4, because it's the distance from the midline to the top and the midline to the bottom of your wave. And then to find the period, we're going to use the number that's in front of x. That's b. This is a. I should have noted that on the last one. So we're going to take, I don't know why I put the equal sign all the way down there. Let's get rid of that. Okay. So we're going to take 2 pi and divide it by 5. It doesn't reduce, so we just box it and move on. And there are extra things in this. If there is a +2 on the end, I think you guys mostly figured this out from the lab. What does that do to the graph?
Move it left.
If it was inside parentheses, it would move it left. So if it's on the end, it would move it up 2. So we're going to put that it's going to go up 2. We call that a translation, but it just slides the whole thing up 2 units, so that your midline is not the x-axis. And then if there's a negative in front of your function, that reflects it over. So say it's, I'm sorry, yes. I heard you, but my brain didn't. So it's also reflected over the x-axis. So basically, the negative flips it upside down. We've talked about that with parabolas in the past. If your A in the front was negative, it was a frowny face, and if it was up, it was a happy face. With this, because it's wavy and it goes up and down, it just flips everything over the x-axis. Okay, so this is where the up 2 came from, and that negative is where we get the reflection from. If you want to put everything on the equation, if that works better with your brain, you can do that. Okay, so let's look at the next one. Let's just go through the list. What would be my amplitude? 2. Absolute value of 2 is just 2. And then the period on this one takes a little bit of work because they have a fraction in there, and that happens quite a bit. We're going to have 2 pi, and we're going to divide it by 2/3. So instead of writing a fraction, I'm going to put the division symbol this way and write 2/3 because I think that helps our brains think about when we did fractions in middle school. When you divide by a fraction, you copy the first number, you change this to a multiplication dot, and you flip the 3/2 over, or I'm sorry, the 2/3 over to make it 3/2, and you can put this over 1 if you want, and then you end up with 6 pi over 2, which is 3 pi. In order to get something with a period that is bigger than 2 pi, they have to use a fraction in here. So that's what that looks like. And just to make a note, sometimes for this part, they will write it as 2x over 3 instead of 2/3 x, and that means the same thing. So if you encounter that on one of your worksheets, I honestly don't remember what it has on there, but it might look like that. Just know that that's the same thing, and you'll just use it as 2/3. All right, so we need to look for anything else. There's no negative up here, so I know there's no reflections, but I do have a -1. So what will that do to my little wave? It's going to move it down 1 unit, so down 1. So I'm going to go ahead and make a note of that. And then there's one more. I'm going to scoot this over. So let's go through the list. What would be my amplitude? 3/4. So there is a negative there, but for amplitude, we just want the number. You take the absolute value. What does this negative do? Reflects it. So I can go ahead and write that if I want. So it's reflects over the x-axis. I'll write that over here because then I'm kind of going from right to left. I've got the negative that reflects. This is my amplitude. And then the 1/2 that's with the x will help us find the period. So we're going to take 2 pi. Instead of writing it as a fraction, I'm going to put divided by 1/2. So we're going to copy the first number, change this to multiplication, so you do the dot, flip this to make it 2 over 1, and you can put this over 1 so they're both fractions, and we end up with 4 pi. And you can always go back and graph these and see if that's what it looks like it will be. It's an option to check. And there's no number on the end moving it up or down, so we would be done with that. We've got everything that happened that makes it different from the parent graph. Now, we're going to go backwards, and they're going to give us information, and we're going to write the equation, which is going to get us one step closer to what we're going to do in the next lesson, which is take a picture, a graph, and write the equation. So, this is write the equation for each trig function described. So they're going to tell us it's cosine. So I'm going to go ahead and write the y equals. I'm going to put COS for cosine. They tell us the amplitude is 4. So where does that go? Before the cosine. And the period is pi. So I need to find b, that number that goes in front. So I'm going to take b is going to be 2 pi divided by the pi that they're giving us for the period. So this is going right here, and it's always 2 pi. The pi's are going to cancel, which gives me b of 2, and that's going to go with the x, which gives you 2x. I like putting parentheses on this so that when we do the left and right stuff, we have a good place to do that. But on these where you're not moving left or right, it's optional. You don't have to have the parentheses. You'll see it on some, and on some you won't have it. And then it doesn't give us anything else, so we don't have to write anything else on that one. The next one tells us it's a sine function, so I'm going to have y equals, I know I'm going to have sine, amplitude is 3, so we just slap that up here, and the period's 4 pi. So this is the only part that really takes any work. I'm always going to take 2 pi divided by this. So I'm going to put the 4 pi in the bottom. So the pi's cancel, and I have 2 over 4, which reduces to 1/2. So then I can say 1/2 of x, or this is the way it usually shows up on my answer keys. They'll say sine of x over 2. They'll go ahead and just stick that x up there with the 1. So this is what you're normally going to see on your equations, but technically that would be the same thing. Okay, so far so good. And then on the last ones, what they're going to do is to start adding little bits and pieces of other stuff we have to put into the equation. So on number 7, it's sine. So I'm going to have y equals, amplitude's 2, so 2 sine. The period is 3 pi, so I'm going to do, okay, b is 2 pi over 3 pi, so the pi's cancel and give me 2/3, so I can do 2x over 3. And then it's reflected over the x-axis. What do I do to put that in there?
Negative.
A negative just with the 2. And then you box that, and that's it. Just figuring out where to put the information in the equation. So then on number 8, they tell us it is cosine. The amplitude's a 1/2, so I'm going to stick that out in front. The period is pi over 2. So when I go to do b, I'll just use this space right up here. So b is going to be 2 pi divided by pi over 2. Whenever they give me a fraction, I like to write it this way because then it looks like an old-fashioned fraction kind of problem, even though there's pi in it, which freaks us out. And so I can make that a fraction, and so I've got 2 pi over 1, change it to times, and flip this over, 2 over pi. The pi's cancel. I have 2 times 2. There's some tough math there. We end up with 4. So I'm going to have 4x. And then it says it's translated down to units. So I like to put this in parentheses just to show, okay, that's what's with the cosine. And it's down 2 units, so you can just stick a -2 on the end. Ta-da! And then they'll just add a few little things, but this is basically what it's going to look like. So the next one, it's sine. Y equals, the amplitude's 5, so I'm going to put 5 sine. Period's 2 pi over 3, so b is going to be 2 pi divided by 2 pi over 3. Copy the first number, change this to multiply, make this 3 over 2 pi. And actually this 2 pi and this 2 pi you could just cancel, or you can multiply it out and get 6 pi over 2 pi and then cancel it. And I always liked canceling out the pi's. That makes me feel good for some reason. I get 3, so that goes with the x, so 3x. I'm going to put parentheses on it because I like parentheses. And it's translated up 3 units. So just put a +3 on the end. So the only part of this that usually people mess up is this part with the fractions. If you get that down, the rest of this is not too bad. One more. So we've got y equals, it's cosine with an amplitude of 1. If there's an amplitude of 1, that means I don't have to put a number there. Oh, it does say it's reflected over the x-axis. So the only thing I have to have is a negative. I just write negative cosine or -1 cosine, either way. And then the period's 3 pi over 2. So I'm going to have b equals 2 pi divided by 3 pi over 4. So I'm going to have 2 pi over 1 times 4 over 3 pi. The pi's cancel, but none of the numbers do, so I'll have 2 times 4, which is 8, 1 times 3, which is 3, so I'm going to get 8/3. So I'm going to put 8x over 3. And that's it, because they don't have anything moving up and down. They just have that reflection.